Hello and welcome to episode 215 of Quarkus Insights. Today what we've got is customer stories of Quarkus in the wild with our special guest, Renzo Cherin. And what we're going to be talking about in particular is Quarkus and sustainability, or sustainable software engineering. So welcome, Renzo. And I guess before we get started with what you've got to talk about, we've got a little bit of news, which gives me the exciting opportunity to push the news button. It's the only reason we do anything in Quarkus, actually, is just so that I have an excuse to push the news button.
Like a kid in a candy store, right? You see the button. I gotta push it. I gotta push it. I gotta push it.
Exactly. Yeah. If we had a button that said explosions, I'd be like pushing that one. Actually, I did have a demo with chicken explosions, but that's completely off topic. I've gone completely AWOL already. So our news is that we have continued with our normal cadence of micro releases. So we've released Quarkus 325.1, but we also had a few fixes that came in just after 325.1 was cut. So we also have a 325.2 that followed immediately after 325.1. So we'd recommend that one to pick up those bug fixes. And our other release news is that 327 is going to be our next LTS release, so long-term support. And we'll be doing a feature freeze before 327. So 326 will be the basis for 327. And we will be cutting 326 this week. So we can expect a period of stabilization in the releases between 326 and 327. And I think that's all the news. Is there anything else I've missed, Eric?
I don't think so. Just any events coming up. I know Java Zone's coming up in a couple of weeks. I'm going to be there. I'm doing a talk with Oleg from Docker on testing non-deterministic things.
Oh, yes. Can't wait to see that one, although I won't be at Java Zone.
Yeah. So then I think DevOps Belgium is coming up in October, and I'm going to be at Dev to Next as well in Colorado in September. Is there any other events?
No, but DevOps Belgium is a good one for us because I think we've got maybe, if you sort of look at the program, there's about 13 or 14 Quarkus related talks on the program. So if you're interested in hearing about Quarkus, then lots of stuff at DevOps Belgium to see. And then, we've got a couple of others as well. So I know I've got Go to Copenhagen and a couple of others, Urdev, that kind of thing. So yeah, it's always busy in the fall with conferences, but get busy.
Yep.
Cool. And I think with that, we can switch to our guest. So it's always we always say special guest, and sometimes our special guests are from our team, so they're not that special, which I always tell them, and then they love me. But today we do have a very special guest because it's always great to get people who are using Quarkus in their organization, in the field, who can share their experiences of that. And as well, Renzo, you're going to be talking about sustainability, which is a topic very close to my heart. So I'm looking forward to seeing this. So I guess, and as well, I should say as well, you've been working with our team for quite a while, which has been great, and you've presented us with some really interesting performance challenges, which is always interesting as well, because they've been fun puzzles for our team to work out. So can you tell us a little bit about who you are and what your role is?
Absolutely, yes. Thank you very much for a very warm welcome. I am thrilled. I'm part of this episode. Myself, I am working for Lloyds Banking Group. I am head of software engineering, Center of Excellence, long name. I'm part of CTO, Chief Technology Office. So I'm a horizontal on the group, and on my team, I indeed working on different programming languages, programming different frameworks, setting up some standard for the group, setting up some template for the group, and testing around to see what is actually suitable for the group to be used. That's my current role, but I am a software engineer in my heart since my teenage time. Yes, I studied in Italy, Bologna University, software engineering, no surprise, and I continued working as a developer many years, architects, covered many roles, 25 years of my experience overall. But yes, sustainability is interesting, always being interesting. I was thinking about reflecting, actually. I think it's something very natural for engineers to try to optimize their machines, their creations, their efficiency. So I think it's something which is coming natural to us as well as software engineers as well. And then maybe as well, historically, I was influenced by some historical events. I remember still a moment where there was a crisis of fuel, something. So I remember there was some shortages of fuel when I was kind of teenage time again, maybe even earlier. And so maybe that influenced me, but I was always looking at efficient cars from fuel efficiency. It's always interesting. So when I was looking at, and that kind of translated probably as well on software and everything. So my early career was indeed in embedded software. So I spent a few years in Nokia, where battery was important and the duration of the battery was something we were paying lots of attention. Hence, software techniques and way to actually work on. It was C++, was Symbian C++ at that time, which was adapted to actually be more sustainable, more efficient on the hardware. And of course, collaboration with the hardware is essentially a hardware on which way you're running is playing a huge role. So that's another influence of my more kind of interest in sustainability. And so when the group, my current employer and the group went with the commitment of net zero by 2030, it was a good positive moment, I think. And so we had this incentive to start actually thinking about how we can contribute as engineers in Lloyd's to be more sustainable business overall. And that's where we all kind of started experimenting, selecting right tools for the right, if you like, job, which we'll talk a little bit.
Yeah, that makes so much sense about the optimization, though. As engineers, James Governor did a really interesting blog a while ago about Backstage and some of the sort of cost insights plugins and that kind of thing that you can get via Backstage. And he was saying, as engineers, we're just natural optimizers. And so if you give us the data, we will do what we can in order to optimize it. So then the challenge sort of becomes making the data available.
You remember something else as well. When I started, and that's show my age, I think I was interested in distributed programming, and Corba was the time, the protocol of the time. And after a few years, Corba was deemed not good enough. So Microsoft went with SOAP. And I was horrified because to send, Corba had binary protocol to send data. So you had usually a byte more than the payload. So if you send integers, it would be probably 6 bytes or something. With SOAP, it was kilobytes, right? It was envelopes, descriptors, everything. And I was horrified, how on earth we can do that, right? Luckily, many years after, we're now talking back about, again, gRPC is now in kind of vogue, which is good, going back to kind of binary models. And SOAP is luckily something from the past.
Yeah, not entirely of the past, because that's the thing about these technology choices, is they never entirely go away.
Oh yes, talking from a banking industry, we still have as well SOAP services internally running. So it is not going away, but definitely it's that direction, which is good.
Yeah, thank goodness. Yeah, I remember one of our performance engineers did an analysis of sort of a packet coming in via SOAP and what the JVM was doing. And, he was just sort of turning gray as he was doing it, because, the amount of garbage, well, literal garbage, that was generated just because everything had to get serialized and deserialized to the string. It was not good.
Yes. So, yeah, luckily, we're back to those days. Was it when they were saying, well, the next generation of the CPUs will just be double the speed, hence it will not be a problem if you blow to the software. And I was very kind of cross with that. I never actually liked that mantra, but for a while it was.
And now look what we're doing with AI, right? The whole AI space, totally not a green thing. We need these mega honking GPUs, and if you look at it like a satellite image of Earth from space, and you see like all the heat of what all these things are generating, it's crazy.
Yeah, indeed. We'll be probably mentioning it later in a conversation. But yes. That's why what brought me here. So shall I maybe bring my slide so we can have some more kind of conversation? Did I actually share the screen all the time? Probably yes. Sorry. Let me now share once more, and I can go to my slide deck and start the slides. In a second, should be up and running. Yep, you should be able to see it now.
Cool. Yep, we've got them.
So we can go for the next slide. So, I think that Holly, you're happy to give some questions if you like. I'm happy as well to talk about the slide. Whichever format works better. I think questions will be good.
Yeah. I mean, I guess to start off with, we sort of talked about sustainability in the bank and the sort of, the broad mission for sustainability. And so then how it's such a huge problem and there's so many things that we can be doing at a personal level and at a professional level. How did you, like, what aspects of the problem did you look at, and how did you narrow down what to focus on?
Absolutely, indeed. So, and this slide is telling the story effectively. So, right, in my opinion, but I think it's kind of known and generally accepted, the fact that there are bold actions we can take whereby we can choose renewable energy source, and with that we'll be already, getting our CO2 footprint low if that's the target, right? If the target is reduce energy consumption overall, maybe in addition to renewable energy source, of which is interesting data as well. There's several data centers in the public cloud offering which are using renewable source of energy, and there is some public data as well available, and I've even seen apparently 96% of renewable resource energy, some data centers in the Nordic countries of Europe, which was quite remarkable and interesting as well data. So if you are having ability to migrate your payload in public cloud, maybe one criteria could be as well how much of renewable energy source is used by those data centers. A second bit, which is quite, I think, fundamental, is about efficient hardware. And I'll tell you here a little story. So when we started actually this quest on measuring some energy consumption of some test services, we started with some small embedded hardware. So it was not embedded; it was smallest pocket PCs. Yeah, was a first kind of testing ground. And the idea was I was plugging in energy meter and effectively reading the energy consumption while I was doing testing on that small pocket PC. Now, that small pocket PC had kind of one of the latest Intel energy efficient CPUs, which is N100. And the interesting point here, what I would like to make is that when I run the test load of, I don't know, it was 400 TPS or something, for 5 minutes, that small box used 5 times less energy compared to a server. I had all server next to me with Xeon processors, server type processors, which was about 8-10 years old. And so the workload, which was running on both boxes on the Xeon processor, 10 years old, was using 5 times more energy for the same workload. And by the way, the small box as well was using only 50% of the CPU, which is quite remarkable as well. So it was definitely within the capacity.
Oh,
so
wow.
that's something which triggered some thinking, right? So if you have just more efficient hardware, you can have multipliers of energy saving without changing any software, right? So we used exactly the same container on both sides. And so, but it's a bigger investment, it's a bigger problem, right? So as well, keeping evergreening, if you like, data centers is quite expensive story. And I believe there's as well mutual interest with public cloud providers, big hyperscalers. They definitely have interest to use less energy. So they are indeed doing this renewal of their hardware. But of course, it takes a long time because it's a huge amount of hardware. Well, that's interesting because that's a big gain, if you like. But then on a little bit less seismic changes, right, is on the softer side, right? And me as a software engineer, what I can do if I have no influence on the hardware because it's in a data center, I have no influence on renewable energy source because again is a contract with energy provider. What I can influence is actually to write my software in a very efficient way. And that's very common, and that's this 3A, if I point in this slide, that's very common pattern stories. So it's very common knowledge about how you can make your software more efficient. And so I didn't feel it's a field which I would like to spend more time because it's, I think, very widely covered. And simple things is about having more efficient data structures or algorithms for search and stuff like that, right? So O2 notations, all that comes there, right? But that was not particularly of my interest because, again, widely known. So what I was looking for which is 3B, which is circled as well, saying, well, how can I actually try to compare different programming languages and frameworks utilizing the same test service and see how much energy they consume? Hence, is there any big difference between them? And that was a quest which we went in. And we were then thinking about actually doing something about it. And here we are. It's the next slide, but maybe Holly, you may have some questions here.
Yeah, I mean, I'd love to know kind of how you evaluated them, because I think certainly a pattern that I've sometimes seen is that someone will have the question of like, okay, well, which is more efficient, and they'll run a micro benchmark, and then they'll sort of generalize from that micro benchmark to a business application, which I think is not the best thing to do. And I think that's not what you did. Is that right?
Correct. Indeed. If you read any literature, research work, or kind of just performance measurements, you will hardly find something which will be resembling your workload. And I'm stressing your workload because every organization, every individual will potentially have a different kind of type of workload, and hence it will be important to evaluate that type of workload. Nevertheless, so what you can find is usually very simple hello world, or in RESTful service side, it was just replying to a REST call. And that was just too simplistic and was definitely not, showing any and it was not resembling the reality. And then other side, you have very kind of computational heavy calculations, scientific simulations, stuff like that, which again was not what we have in our kind of usual day-to-day activities. So what we decided is we'll write ourselves a test REST service in multiple languages and frameworks so we can test it. And we'll kind of have operations which we see in our workloads. Well, in our workloads, we definitely have some cryptographic decoding, encoding, validation of tokens and zero trust patterns. So lots of kind of crypto is playing in. We definitely have databases, and so definitely database access is one of the must-do potentially, usually. And then we have microservices nowadays, and so we have calls to other REST or sister services. So we have a few other REST calls, and all that is today mostly done in REST and JSON. Hence, the marshalling of JSON is something which is happening every time. And lastly, it will be just simple percentage calculation was one of the kind of computational elements of the test application. But again, that's because indeed the heavy lifting is typically not happening in our kind of peripheral, if you like, REST services. But that was something we felt will be representing our workload.
Yeah, I think that's super important too, because people talk about, and you kind of hit on this a little bit, Holly. People do benchmarks and just because it performs this way under this load, it's not representative of what we actually care about. So kind of the context matters of what's important to you. What's important to you in your organization might be different than what's important to me in my organization.
Exactly.
Yeah,
yes.
And I think sometimes we kind of imagine that there's this like one fastest language, and there isn't. That it will depend, which is such an irritating answer, because then it means that we all have to do the work. But
well, that's the best way, is to do yourself, your research, your work, and you create your test application. And I totally agree. So it will be different result potentially by different organization, different workloads. But nevertheless, if your application will kind of look like more or less using similar mix of activities, then the results are going to now you will go to see it will be maybe relevant to your organization as well. Just wanted to mention here that you can see many benchmarks which are potentially not having at all any IO operations. And well, yes, you have to reach the network, the service itself, but that's the only one. Then you have some hello world or computational in memory and then responding. That is good for that kind of payload, but it's very much misleading, because if you think about, there is order magnitude difference in time spent to reach out via IO, so network, database, reading to computation in memory. So computation memory is probably nanoseconds, and going to a database via network, it's maybe not mainly, there's milliseconds definitely, and dozens and milliseconds used there. So it's all the magnitude difference, right? So it is important to as well have this evaluation: how much of IO and what kind of IO you're doing, or how much of in-memory computation you have, in-process computation.
Yeah, exactly. Yeah, and make what you're doing in your benchmark roughly match what you're doing in the real world, because otherwise there's no point.
Exactly.
Yeah.
Exactly. And so, here in this slide, we're kind of describing the test approach we had. And so, again, that's another one which I use the standard library where possible. The first one was one of the important discussion points as well. And many of my colleagues were screaming, saying, look, but this library is much more performant, right? But because we're a big organization, right? So we are an organization which need to have as well audits, and so utilizing kind of the best of the breed is not necessarily good for my type of industry, if you like, right? So the small niche libraries, which may be maintained by a small number of very passionate individuals, were potentially not a good answer. So the approach was here to use a standard library wherever possible. So if the functionality is offered by a standard library, that will be the one used in our test. Again, we were not looking to do any parallelized way of, because there is opportunity to do parallel calls and stuff, but that will kind of complicate the implementation. And again, for what I can witness in kind of big numbers in the whole organization, our code tend to be quite simple and be kind of very kind of basic in many aspects, which again is positive from maintainability point of view. And so again, we were not looking to sophisticate anything. We were just having a sequential, simple code, which we're doing one operation at a time, because that is how, in a while, at least in our organization, is most likely to happen.
I think that's important too. I mean, I used to teach. I worked in financial services, and we used to teach the code that you write lives for, I don't know how many decades does code live in the organization. Write it for maintainability first to make it easier, and then if you run into a performance problem, then tweak it for performance. And
Precisely.
because then you end up with like these methods that nobody ever wants to touch, and you copy them, and then you comment that like I didn't want to touch it because I didn't know what it did. Right.
Absolutely, indeed. So that's exactly the approach we had here. And then what else? When we run on Java, we run on JVM. And for that, we also had a warm-up time of 5 minutes, because we know that JVM has a magic element of just-time compiler, and it will do magic if it has time to learn about your code, your workload. So a warm-up time is important for testing, and because again, it's realistic. Yeah, if you're talking about long-running services, it will be there running 24/7 for a long time. And then we used 5 minutes kind of constant load to measure and we have a driver running on K6, which is a library. I think Grafana made it, which we found quite useful. And then we worked well. Workload was on a single node running on GKE, because again our workloads are on Kubernetes, and hence Kubernetes was our runtime environment here, and we wanted just to measure energy consumption on one single pod, if you like, which will run on a single node, and that will simplify that. And then we use the GCP as our kind of testing environment. And in this picture, you can see on the right-hand side, there was this Kubernetes cluster with one node. It was using managed service Prometheus from Google to collect all the metrics. And then on a separate subnet, on a VM, actually, we had a driver K6, which was creating the load, warming up and creating the load. And then on the same VM, we had running the REST service, which was used for calls on the REST service, and the database, which was Postgres database. We tried many other configurations. We tried with Postgres as a separate service, as managed service from Google, as a separate kind of VM. But in all those different configurations, we found that was actually not making any difference. So I'm just showing that as for simplicity here. It's all in one VM in a separate subnet, all the kind of dependent services and the databases which we use for the testing.
Yeah, that's interesting that it didn't make a difference.
Yes, that's why I've done the test.
Yeah.
Say, look, I would be interested to see if it's because, well, no, it depends on the cloud provider, isn't there? So which kind of service they will offer. Because we run it on GCP, in particular, we have this AlloyDB, which is Postgres compatible, or Postgres itself, as a managed service. And then you have Cloud SQL, Postgres variant, if you like, which again is managed service. And then we run it on a separate VM as an independent Postgres database. And all that testing on those kind of variations did not actually show any major difference, which was quite interesting. So we have those kind of set of results, but didn't actually bring it here because it was not of interest. But yeah, it was interesting to know that probably because again the story of quite slow probably access to the database overall is probably not having a major impact because the waiting time is more or less in an order magnitude the same regardless of the database leaves. That's one of possible takeaways, but you may have some others as well. Any ideas?
No, I'm in suspense here, so I want to know what the results of the experiments were.
Here we are. So that will hopefully be the next page, if I remember well. Yes.
Cool.
So this is a graph view of our results. And Holly, can you understand? Are you able to read it? Is it immediately?
I think so. Yeah. So I think, I do have to.
So I guess it's a little bit of hints here.
Yeah. Let's go.
So on the on x-axis, you have transaction per second, TPS, which we started with 400 was a starting. It's not 0, that's wrong. Sorry, that's an error here. It was 400 as a kind of minimum, and then we ramped up to 4,000 TPS on a single node. While on the y-axis we have a CPU second. So how many seconds CPU, how much time the CPU has been used by the application, by the workload. And then the different lines will indicate different combination of languages and frameworks. Lower is better because less CPU time used, which will represent with a rusty color. Notice the
Oh, I see what you did there.
yes, the link. Yes, that's rusty color is the lowest, and that is shown being the best performing in our testing. But then you can see this green, blue twisted lines, which are representing Golang and Quarkus. And then you have another interesting black line because it is really high CPU utilization with Spring Boot. That is, and to be honest, so we run this several times. We have kind of internal reviews, everything. So it has been tested again once more, and it was quite consistent results we're getting. Now, I can maybe talk about the next slide, which is giving me a table view of the same.
So are we talking about all on the JVM, like all of Quarkus, Spring, all on JVM, or native, or what combination?
On JVM. We're talking about JVM with warm-up time of 5 minutes, and after that we started measuring the CPU utilization. That was the gist here, and indeed I'll be actually mentioning a little bit about native version later on. We'll come back to the native version. At the moment, it's JVM only, right? And so yes, maybe I can talk about total CPU core seconds. The idea is that number is proportionate to energy consumption, because the idea here is that number should be just multiplied by the energy consumption of the single core. So how many watts the single core consumes, and you multiply by that time, you got energy consumed by that workload. So after the debate we had, we did manage to settle on our value to go after is how much time the CPU was used. And if you have something more than 5 minutes, if you like, in total core seconds, because you have multiple cores, right? So we had just one node, but that node had, I think, from memory is wide, it had 4 cores. So you can have up to 4 times the duration of the test consumption. Now, it's tricky, right? It's a good approximation, because having a very precise measurement is tricky, right? So having just this kind of multiplication of the core consumption per seconds used is a good approximation. Why? Because especially modern CPUs are doing lots of trickery, right, to reduce consumption when not in high demand. Hence, you have all this variation in frequency, but also you have switching on and off the cores. Cores are not always necessarily switched on. And lastly, as well, I think the last CPUs from Intel, if I'm not mistaken, are having even some, they call it peak, what they call energy cores, and the kind of power cores. Yeah, something like that. They use kind of some of the cores, let's say half of the cores are kind of energy efficient, and then have half of the core are tuned for performance, which are eating lots of energy but are extremely performant, and they switch them on and off on a weekly basis. So that kind of multiplication per watts, if you like, per core is a good proportion, but it's a good approximation. It's never been a precise number, but I think it's good enough.
Yeah, certainly. Yeah, it's a very useful proxy, and I think like what's so fascinating about these results is there was a paper a few years ago that went sort of viral in some circles of the internet, that compared various programming languages for micro benchmarks, and you've done a similar thing, but with a real business application, which is great. And going back to the sort of the discussion about how your benchmark needs to match your workload, what the results that you've got are a little bit different from what they saw. So they saw that Java was about half the energy or twice the energy usage of Rust, and the difference that you saw for those kind of business level applications is much smaller, isn't it? And then you saw that Quarkus and Go are super similar, which is again not quite what they saw.
Mm-hmm. Yeah, it was a little bit surprising, if you like. So, but again, we tried it several times. Now, again, remember when they're saying colleagues screaming, if you use a more efficient library here, there, you will get much better results. That's probably true, right? So, if I ought to put in a mix for the other programming language like Golang, for instance, kind of more efficient network libraries and RESTful libraries and routers, right? Which I think you may know, but there are at least three. There's recently standard implementation. Historical was Max Gorilla, and then we have Gene, and we have Fiber. Turns out at the moment Fiber today is kind of the most efficient of all. But again, I went with this principle. I don't want to use something specific. I would like to use a standard as much as possible, and Golang offers a standard. So standard router was used in this testing, which potentially was not giving the interesting, not giving the boost where potentially we are expecting to see. Rust, I don't know. Well, the story here is that, again, we had a simple implementation with standard, standard, there is not standard network. There is this kind of Tokyo, if you like, set of crates and libraries in Rust, which are kind of de facto standard, which we use in this case. So those are interesting results. But, the results in sustainability are, one of important values, if you like, but then you have to consider all the rest of the ecosystem and the maturity of the ecosystem, everything, especially for the banking industry. It was important to have other as well parameters in the mix. But let's go back to these results.
I'd be interested too, and I don't mean to interrupt, but as a Java person, obviously I love Java. Like, what the ease of programming in doing the same kind of, like, how much code did you have to write? Was it more? Was it less in Rust and Go? The comparative, like, debugging and kind of the non-functional, hard to measure stuff too, like how that shook out.
Yes, very good question. Well, we had actually interested for this exercise. We did not particularly pay lots of attention in those kind of angles, but they would be interesting. I can definitely tell you from seeing the sources on all those implementations. I think the most difficult potentially would be Rust one, and the Quarkus was potentially the simplest one. Go was something in the middle, was on the simple side. Go definitely. But with this, reducing the boilerplate code in Quarkus is quite remarkable. And so you have whereby, most of the things are done by the frameworks. And so you have to basically write just a few lines of your business logic, which is quite easy, if you like, or a smaller amount of code needed to be maintained by the team. So in my opinion, again, we had no extensive, we didn't spend much time on this analysis, but from more kind of gut feeling and reading the code, and partially actually written by myself, some of those. So I would say that, complexity-wise, Rust will be number one. And then you have potentially Go, Spring is kind of ish, in my opinion, and Quarkus will be potentially the winner on simplicity of the code.
That's consistent with what we hear elsewhere, and I find it so interesting because I say this all the time, but we sort of expect that there's this trade-off between performance and complexity. So, which is a little bit like what you were just talking about with, well, we could squeeze some extra performance out by going to these non-standard libraries, but then that's if we do that, we're sacrificing the maintainability, and it's, you know, a heavier lift for our teams to get started because they have to know to go use that library. And if you look at something like Rust, you know, it seems to follow that pattern where you've got that much heavier intellectual lift in order to, you know, even just get started, but then you do get that extra performance, but maybe not as much as you thought you were going to get. But then Quarkus kind of breaks that trade-off because you get the really great developer experience, and then it also has, you know, that fantastic performance, which is just so cool.
Yes.
Seesaw with the seesaw graphic that comes right to mind that you write there on your slides.
Yes, yeah, absolutely. Yes. And maybe just a word on memory consumption here, which would be interesting as well to mention. So as you can see on compiled languages, it's small. It's kind of around 10 megabytes roughly. On JVM languages, it is much bigger. It's about 250 roughly on Quarkus, but a third more on Spring Boot. So again, if you look on JVM side, you can see that consistently Quarkus was using half of CPU time, or hence half of energy or half of infrastructure compared to Spring Boot, which was quite remarkable in my opinion. You can see those numbers right now. Take 2000 was 400 seconds versus 900 seconds in Spring Boot, and that was consistent more or less across the board, right? And then the CPU, yes. So memory I was going to say. So memory was one of the, again, debate points, right? So saying that surely having much more memory consumed compared to compiled languages, there must be some advantage, right? Or disadvantage in JVM languages. Well, in my environment, in our kind of runtimes, that does not actually play in that way, because now again, it's very much subjective based on your kind of workload, your environment. But what is the gist here? From literature, you can see that the memories computer memory from my memory consumes about 5% of overall kind of computer power. Now, that has to be validated because that's coming from my memory and I read it a long time ago. Nevertheless, will be this order of magnitude, let's say about 5 to 10%. And fun enough, it is always powered. Yeah, it is always on. Reading or not reading, using or not using, the RAM memory of a computer will always be consuming that amount of energy. So it is not kind of dependent on use or not. And that all brings us to a story that the typical node in a cluster in our environment will have something about, I think, 64 gigs-ish. Hence, the memory actually is not a bottleneck. What we see, the bottleneck on pod density in a node is about actually CPU utilization, because the virtual CPUs available on a node is the factor determining how many pods you will be able to fit within a node. So pod density will be proportional to CPU utilization per pod, and that's the bottleneck in our environment, right? So memory is not. Hence, having high memory consumption by JVM versus the compiled version, well, compiled languages in this case, it's not a big deal. But for us, for others, maybe, right? So that's something important to be noted.
Yeah, that's such a good lesson in terms of optimize what matters for you rather than just optimizing things that look good on a chart that don't actually move the needle in your case.
Yep, exactly. And then on the native version, so if we do compile Quarkus service, the memory consumption goes down to about 30 megs in our measurements. I haven't got this data because it was not kind of very. So about 30 megs was the consumption of memory for compiled version Quarkus. However, compiled version of Quarkus was in order of magnitude of Spring Boot as per total CPU utilization. So energy consumption was higher versus the JVM version. And that's something interesting to note. Maybe indeed this slide. Sorry, I forgot I had this slide. So shall I crack on this slide?
Yeah, definitely. I think, yeah.
Okay, cool. So yes, we did mention why not compile Java. So compile that surely will be better. Well, not in our measurements, in our experience. So we definitely see, and Holly, you were talking about in many of the events and sessions about the instant startup time. So what was the story about the LED? I think was quicker than lightning LED. So it's very much quick and instant on startup if you have compiled version. Of course, you don't need any warm-up time, so it is always ready to crack on and very efficient to the extent that implementation is able to. You will see memory consumption much lower, kind of 10 times lower-ish, right? So automatically less than the JVM version. However, we measured much kind of worse CPU utilization was kind of doubled to JVM version, and that was comparable to Spring Boot. And now, conversation I had in the past with Red Hat team, Quarkus, and you, Holly, as well. I remember one of the calls we were talking about. I think one of the reasons for that is not so sophisticated garbage collection, and JVM just-in-time compiler potentially could do some really kind of clever compilation of the parts which matters. And so overall, the native version is not so performing on the CPU utilization, right? It has other benefits. And because of those benefits, it has its potential use, right? So we believe, and here we have experts on the call as well, so we believe that it's not a good choice for long-running service, essentially, right? Will be much better for a serverless use case, where you have a quick startup time and very short-lived service, and then you die and you go back to your shell before the next call. And that will, I think, good choice for the compiled version of the Java service.
I think that's consistent too with what we've seen in the wild, not just with Quarkus, but with native Java. Like, take your framework of choice and compile it to native. It has its use cases and it's good in certain places, but I typically say like 80% of your workloads probably belong on the JVM, especially if they're long running.
Yes. Holly, I remember as well, you were as well having another use case whereby you can think about having a burst kind of mode for native version.
Yes. Yeah, that's a really good point. So that you don't have to choose either native or JVM. You can have the bulk of your expected workload on JVM because it's going to stay up and it will have the higher throughput. But then you can do sort of like what we used to do with cloud bursting, where you'd have the bulk of your workload running on-prem, and then if you had a spike, you'd go out to the public cloud. You can do a sort of a similar thing to shift load between JVM and native, so that if you get a spike in workload, then you can really quickly bring up these native instances. And it's worth saying that the startup time is less, but then as well, because they don't have that warm-up time, once they're started, they will be at their peak performance, which is a lower performance, but they will get to that peak performance quicker. So it really means that you can feel pretty able to just bring them in when you need them and then get rid of them.
Indeed. So that was something we definitely have seen. And yeah, so if no other question about native, well, maybe I can mention as well. So I don't know how there are two native compilers, but we tried both, right? There's two. One is Red Hat upstream fork, I think it's called Mandrel, and second is Oracle GraalVM. And we haven't actually seen any differences because eventually they're coming from the same code base. So running compiled version on any of those works quite all right from the performance point of view. I don't know if you want to go to the last kind of other consideration slides, or we maybe would like to have a little bit more conversation on that. Probably.
Oops, nope, speaking on mute. Yeah, I think that we can just sort of talk through. So now that you've kind of done these experiments, what kind of advice are you giving to the other teams in Lloyd's, and what kind of advice are you giving to them if they're adopting Quarkus?
Well, the advice is quite clear, right? So if you're running, if you're actually going to do a greenfield new service, greenfield in Java, you should think using Quarkus framework as default, because that's shown to be definitely giving us unnecessary performance, sustainability, but also other benefits on easy coding, developer happiness, and so on. So there's lots of kind of benefits of using it. However, if you do have, of course, all applications which need maintenance and enhancing, well, we are pragmatic, right? We cannot have it all immediately, but in time we will come there. So the existing application will be maintained in a framework or language which is implemented without any particular changes for time being. While saying time being, because we're always interested to see if there'll be some way to automate maybe some migrations from old to new, and if that will be something viable and usable, then that will be something where we probably start actually recommending to our teams. Then back to developer experience, which is quite important factor in all that. So we found that with Quarkus, we do have quite easy migration, if you like, because big chunk of our developers are kind of knowing Java and the Spring world, and so going from Java Spring Boot to Quarkus is deemed quite easy migration. By the way, Quarkus is not something from the space, right? It is made of other frameworks, so other libraries, right? So it is still Jakarta there. It is still compatible with microprofiles. So there's lots of standards already there, which are well known to our developers. Hence, it's not something which is completely alien, right? So it's definitely very familiar kind of set of libraries which Hibernate is there. So there's lots of things which are used by normal Java developers. It is just that it's helping with less boilerplate code. Hence, there will be some additions like I think Panache library for database access, which is reducing boilerplate code to almost nothing if you have standard queries. So all that is a bit of learning curve, but I think it's very healthy to not be too static in one environment or language for too long. It's nice to evolve and kind of get a little bit of a new way of doing, which could help your productivity as well.
Cool. And we've been kind of talking mostly about, I think we've been sort of assuming that these are production applications, but of course there's also like all of the staging and the test and the build and that kind of thing. Did you think about the energy impact of those environments?
A lot indeed. So, big projects could have 24/7 running infrastructure supporting your build and test. So that's something which we need as well pay a little bit more attention on, because it is another service, just internal, right? So it is something which is still running. And then I think there's element of mindset whereby coming from traditional on-prem infrastructure, there is no incentive to kind of reduce your infrastructure footprint, because was there running for you regardless. And so there is this, unfortunately, still mindset from old days, whereby if I start my pipelines, CI/CD testing frameworks, they'll be there hanging around and running, not necessarily doing productive work. So first bit is maybe getting to more on-demand, spawning infrastructure requests for demand, doing your workload, your testing, and then shutting down and reducing your footprint as much as possible. That will be the direction. And then again, select your VMs, or if your VMs or clusters and nodes to be proportionate to what you need. Cost is there as well, not only energy, so that is as well very, very kind of linked very closely. So, don't have your supercomputer running for maybe simple tasks. Do it in a proper kind of proper dimensioning of your infrastructure will be important, right? Database, for instance, you can have a monster database with petabyte data, but for your testing, you don't need it. So how about, maybe using small database, maybe even on container for your test, right? You can have this ability to recreate your data sets on the fly because just respawning the container. So there's lots of techniques we should be thinking of and implementing so that we reduce cost and energy as well consumption. However, you remind me something, because one of your talks, I think, was with another partner in crime of yours, was talking about how you can have a clever reducing your test amounts on your code, right? While you are testing always the same, while you haven't changed anything. So there are tools, libraries, and ways to actually select a subset of your test you should be running against your change in your code. And that reminds me, actually, a long time ago when I was in Symbian days, we had a brilliant grad who actually even did a pattern and for a tool who he thought, because at that time we were having hardware tests, so we had actually hardware farms, lots of hardware devices which were run overnight, and lots of tests, lots of energy, So the idea was indeed to understand your change, which of the tests we are running will be actually executing your change, your function, your place of the code you changed. And so that reduced a massive amount of testing. Rather than doing it for 3 hours, you can do it in 15 minutes if your change is small, and which is typical, right? It's just kind of very much limited in one place. And I think there are tools out there to actually do exactly that.
Yeah, I mean, we do something very similar in Quarkus. So if you're a Quarkus user and you're running in continuous testing, if every time you typed a line of code, we ran your whole test suite, that would be a nightmare for you. So we use kind of like a reverse code coverage technique. So it's, very similar. So we figure out this line of code affects these tests. So these are the tests that need to be run. But I think as well, so that's sort of, that's kind of at the code instrumentation level. And I think maybe what you were thinking of earlier as well is I've done some talks with Trisha G, who is at Gradle, and so they do the Develocity tooling, which allows you to have this kind of predictive test selection. And I think there it's getting sort of more into kind of a machine learning algorithm to say, well, this is the area of the code base that anytime anybody touches, everything breaks. So let's run all the tests for that one.
Absolutely, yes. I think that will be, again, engineering nice problems to solve and to optimize, back to optimization, how we started.
Yeah, and still on the sort of the infrastructure side, I'd love to talk about your experiences with logs, because I always sort of have this mental model that like logging is free because it's boring. And is that actually what you found in terms of energy consumption?
Yes, you can see my reaction on that. Yes. Free for the people which are not paying the bills, right? Yeah. No, well, there is definitely a penalty, not only monetary. So it's penalty on your CPU and your energy. And there's a little interesting story to tell here, because initially when we started running our tests, we were lazy and didn't want to actually go to understand the pod consumption of the CPU, because it was a single node. We said, how about we measure it on the node level? That will be easier. So we measured on the node level the CPU utilization. And then when we compared to different frameworks, we have a huge difference. And we could not understand why. And to actually nail down to the logs produced. So we had the log forwarder there, which was an agent running on a node, which was sneaky and consuming a lot of CPU when there was lots of logs to be transferred, and then was going kind of in hiding when there's no logs to be transferred. But that kind of spikes and problems are very kind of problematic if you have really lots of logs. So the first direction is to reduce your logs. So of course, info logs, everything should be by default. And so you should think about what is your logging strategy? What is your kind of important information you want to log? In banking industry, there's as well some must-have. So there's some elements which need to be logged because of regulatory environment. Hence, and especially if you have some hiccups in your forwarders, agents that accumulate more logs, and when the server comes back online, you can see how many CPU is used on just forwarding the logs out. So producing logs, saving it locally, but also forwarding those logs and filtering those logs, because those agents are filtering logs as well, that's eating a lot of CPU. Hence, messages, think about your logging and log only what you really need.
Yeah, makes sense. And then so that hopefully that comes back to the developer experience win as well. You think you're being a hero by putting in all of this logging, and actually maybe you just have to go take some of it out. So be a bit more thoughtful before mindlessly doing the work for you, which then turns into the work for the computer.
Yeah, and I remember too, we used to do so back in the web start days, like in applets and whatnot, we used to log everything to the console, and we used to see, because it ran on the client desktop, that it would spike the CPU whenever it wanted to log out. And because Swing and web start is single threaded, like your processing of what you were trying to do had to wait for the logs to finish writing. And when we moved, like we rewrote the code that did the logging to like hand off to an asynchronous queue, and then a separate thread which read the log messages off the queue to the console. Like our whole application sped up and our CPU went down. And it was amazing. Like to your point, like nobody really cares about logging because you think it's free, but in reality, it's really not.
Not at all. Not at all. And there were circumstances when you actually affected your service, because it is so demanding on your CPU that affects your service. If you have some, real-time services where they have some high kind of TPS services, you can see actually affecting the service because of the spikes of logs.
Oh, I've got like a million more questions. I think we could keep talking forever, but I think we should be respectful of your time. But so is there anything sort of else that we haven't covered that you want to talk about?
Well, I just want to repeat that I think that everyone should actually do their kind of little bit of data-driven decisions on the workload they're having, and so maybe if it's far away from what you've seen in the slides I had, then definitely it's important to actually collect your data, and then based on your data, you can then judge what is the right tool for the job, right? So, and that's important bit, to choose the right tool for the job, because I hate when we do, one size fits all. It does not usually. And of course, there are compromises always being, but please, be data driven. So do a little bit of your analysis, and then you can choose as well a mix of libraries which makes sense for you, because your environment is maybe more keen to have more maintenance, and you go with some maybe top performing libraries, but less maybe established ones that will give you definitely energy benefits. But then you have to have more time on maintenance side on those libraries. But yeah, it's always a little bit of balance to be struck, but I think it's important to be data driven. That's the key.
Yeah, that makes so much sense. And I think certainly for you, like, you can kind of see that the time that it took you to do those, and, took your organization to do those experiments, is going to be paid off so many times in terms of having made the right decision with the right information.
That was the intent, indeed. But yes, there was a mention of AI. What AI?
Oh yes, yes. We couldn't possibly
Come on.
not mention AI.
Well, no, I think there's very, very important element here is that at the moment AI is consuming a lot of energy. It costs lots of money if we do actually use the anger. So we're in hype. Yeah, definitely we are, and we'll see how that will evolve, because time will show. But at the moment, the hype is totally probably not considering energy aspect and cost at one, because using it at the pace, it is quite healthy bill as well at the end. So I think interesting. I think that things will need to kind of come back to normality, where the hype kind of little bit kind of vanishes, and then we start thinking about, how about if we do really want to have a service payload which will be using AI, what will be a combination which is right for the job. Because again, one size fits all is potentially not a viable solution from the planet, but also from your budget problem.
Yeah. Yeah, and I think with AI as well, I think we may see that sort of similar trade-off as we saw with Quarkus, where sometimes the more efficient one also gives you the better results. Because we see that a little bit going back to the sort of the right model for the job, that sometimes having a smaller context window or certainly a smaller model can actually give you better results than the kind of, the one model to rule them all that we imagine is just, if we make the model big enough, it will be able to answer every question. And actually, it gives lower quality answers for more time at a much higher cost. So if you can have those sort of orchestrated sets of small models, it's that double win again, and it's cheaper.
Precisely, exactly. So yeah, I think that will be the final thought.
Yeah, excellent. Oh, well, thank you very much, Renzo. Yeah, super interesting. And
Pleasure. Thank you.
oh, yeah. And I think we are. Eric, do you know we're back next week, aren't we? I think.
No, I think we have a break next week.
Okay, we have a break next week. Oh, yes, we have a break next week, and then we're back the week after.
Yeah.
So we're continuing on our summer schedule. So we'll see everybody in 2 weeks, and thank you again. Cheers, Renzo.